Hello, this is Eric. I have got another Minikorg on my hands. This one's pretty nice. That's new. Or maybe that's not new. No, I think it's new. I had a toggle switch on another one. This key's a little tweaked. So of course, I've got to figure that out. The wood's exactly what you'd expect it to be. I gotta take a look at it to see if it's a veneer. These are great scents. This one has a bad oscillator, so I got a new one. This effectively is a custom integrated circuit. Check it out. So those are the pins. You desolder the old one, pop in the new one, and if the history on this synth is accurate, which I believe it is, it should fire right up. The keys are really dirty. I'm going to have to take them all out, clean this thoroughly. Everything's a little dusty. I'll have to check for mobility on all these, probably lubricate them. There are felts behind these, at least there should be, to keep the dust out of the potentiometers. Sometimes these switches don't make good contact, so you may turn it and it won't actually activate. But that also can be cleaned up easily with just some, electric cleaner, contact cleaner. Everything sounds and feels good, and that's because the previous owner was gigging with this regularly. I don't know what you think about gigging with vintage gear. I don't do it. Have I done it? I don't think I've done it, but I guess I would. Why not? Could be fun. Anyway, I'm going to open this up. I've got to take some readings on it to make sure that it really is responding the way it should. I should get the proper voltage out of it. I'm going to take a look at the PSU. The last one I had, I did replace a couple capacitors on the power supply unit. Other than that, the construction is pretty simple. There's two main circuit boards in here. One has the oscillator on it. It's a single oscillator in this model. The other's got the filters. And then, because there's a ton of controls, there's a lot of wires coming out of this front panel into the different boards for controlling all the parameters. That's a great synth. The filter is really good and lets you do interesting things by having these two controls you can adjust at the same time. Alright, enough of that. Let's take it apart. Just to give a little insight on how to get into this synth so you can work on it. You take off the screws for the metal cover. There's some in the back that hold it in, just a couple in the front. And then it gets you down to these wooden side pieces. They have screws on the top, but they also have a hidden one underneath the end plate. So you got to remove the cheeks in both cases, and then you can get the other screw out and take out the wood. Then you've got to remove the keybed. The keybed screws are on the bottom. They're really big, sturdy screws because it's crucial to lock the keybed down. Once you get all that done, you can get down to these nice vintage circuit boards. These are great. These are just single-sided, all-through-hole components. You will not find a single modern IC in this. So let's finish pulling this one. All right. So while I got the wood in my hand here, what do we got? So it's plywood, and I guess it has a veneer on it. So this can be refinished. I just did it on this beautiful drum machine. That actually is plywood. Sanded it down, vacuumed out all the sawdust, and then stained it with Danish wood oil and put a poly coat on it so it's got nice shine and protection. So I could do the same on this. This doesn't look bad. I mean, it looks really good, and I'm not going to go and get plastic wood and try to fill in the corners and reshape it and make it look like it's brand new or something, because it's not. It's 50 years old. It's good looking. Has some character. All right, so now that's the hidden screw I was talking about. Can remove that. Just little wood screws. Now, there we go. Getting a little closer to being able to do something. There should be a fuse. There's a fuse holder right there. We'll start testing this all out. Oh, and there's a third circuit board. It's the power supply board. It's right there. It's got a very interesting rectifier assembly on it. I think that's what it does. It's either a rectifier or just a really high voltage regulator. It spits out like 20 or 30 volts. But we'll see all that in detail. So keep watching. The big screws are for the keybed. So we're going to take those out next. The keybed's got to be, to make life easy, I want to completely remove it, detach it from the circuit boards. It looks like somebody made my life easy. That adapter right there looks like a 4-pin Molex plug. That is awesome. That will let me simply unplug the keyboard and get it safe and out of the way for the ensuing work. This keyboard, the Korg used what is it? Hertz per octave. Slightly different technique than the Moogs, where they used a volts per octave, typically like 1 volt per octave. So it's a little different. Oh, we can see some of the damage. Why this key is tweaked. Yeah, probably what happened in shipping. I might just be able to buy a new one of those. I'll have to check that out, because you're not gonna repair that. A repair just wouldn't hold. Well, maybe. It would be possible to attach a splint piece of plastic all along the side here, and then you just cut a little notch in it, and you've got a repair. So we'll see if they're available. Otherwise, I think I do have an option to fix that, as long as there's nothing else wrong with it. Alright, one step closer to getting to the circuit boards. This I'm on the floor underneath the synth. When you're taking out a keybed, you don't want it to shift, and since your hands are kind of occupied using the screwdriver, the easiest way to remove them is from below. This way, it's not going to move. You get all the screws out in a nice controlled fashion. Now I can pull that Molex connector and lift the keybed out and put it in a safe place. They pulled the oscillator. That's fine. Said it was bad. For some reason, they didn't know you could buy a new oscillator. They didn't know this was repairable. So they told the owner it couldn't be repaired. And then they didn't even put it back together. This is how I just got it. You know, they didn't even put the circuit board back in that the oscillator came off of, which luckily it doesn't appear to have caused any damage. But come on. You have some respect for the gear. Now, interestingly, so look at the pins here. There is one pin still there, and I know that it has to be removed. So I don't know what they did there. They just broke it out, I guess. Yeah. So I guess in some ways it's going to make it easier for me to install the new one, since, you know, the old one's already out, mostly, except for that one pin. Now, as for the power supply, not knowing how much I trust these guys. Oh, it says okay. I don't know when that was written there. That could have been written there 40 years ago. But there's just a couple of leads that you can lift from this board, from the power supply board, to detach it from the rest of the synthesizer. And that way you can, I guess there's like 2 leads on each board. You can power it up independently of the rest of the board. If you have any doubts about the board, I'm still going to say I don't really have any doubts about it, because it had been being used by a gigging musician up until this oscillator going bad. Now this is kind of neat though, what I want to show you here. Right there, that is a new filter. So that is the original filter. It's called potted. It's completely encased, not just a plastic shell, but this is, I believe, a solid chunk of plastic, liquid stuff melted onto, you know, these components to make it really, really hard for anybody to figure out how to make a copy. But that's cool. So this has had some work done on it. Power supply connections, I appreciate these. These are pretty good. I've seen various boards that didn't have good work done on power supply terminals like this. I did notice maybe one wire here. It just feels loose, and feels like it's a stranded wire, and it feels like there's very few wires in the strand actually soldered in. It just feels really weak. Now this power supply, again, people have done some work on it. These are, you know, drawn on by somebody. I think these have been replaced. These are the main capacitors that help store the voltage coming out of the rectifier and smooth things out. So if you're going to recap it, those are the ones you replace. I could look at some old pictures, because this is the same type of work I did on the one that I had. You can calibrate the power supply, make sure it's good. You can calibrate everything in the synthesizer, of course, both on the oscillators and the filters. Calibration serves 2 purposes, I'll say. One purpose is components drift. Components are not always, you know, what you think they're going to be. And if it's a circuit that requires components to have, you know, a really tight tolerance, one way to avoid that and use less expensive components is you put in ways to calibrate it. So now it doesn't matter if my resistors are kind of cheap resistors, if I've got a way to adjust that circuit by using a trimmer. So that's what people do. So I guess this is rust. That's okay. That happens. I'm not gonna take it apart and sand it and paint it. Get rid of a little rust, I don't think. Sometimes I do some of that. Now it'll be interesting to find out if all these connections are still good, and to see what kind of power. This is the funky power regulator that I mentioned. This is interesting. I haven't seen these in any other synthesizers. They're probably in a ton. I'll probably blow up in the comments, oh yeah, that's in this and this and this. I usually just see rectifiers, either a single rectifier unit or something like this, which is a homemade, not homemade, but it's not a integrated circuit approach to a rectifier. So you've got these 4 diodes here, you've got these 2 big capacitors. That immediately identifies this as a full wave bridge rectifier. So in this case, what happens is the power comes from the transformer. AC in, AC out. Right? That AC hits this regulator, if I'm recalling, lowers it, stabilizes it, and then goes into the actual rectifier, which produces DC on the outputs. The outputs actually tap off the junctions of the rectifiers, I think. Very standard circuit that you can go and take a look at it. I do want to take a look at the circuit to see where that fits in, make sure I'm telling you the right thing. So in any case, I want to power this up, check the outputs in a couple places. I've got my notes from previous work on this. I'm hoping they will tell me exactly what I need to know. Actually, some of these are labeled properly. Look at that. There you go. That's a good one. And right there. So that's handy. Handy way to test this. See what voltage we have coming out. Oh, and this is another voltage there. So positive and negative voltages coming out of this unit. Time to power on. So there was a casualty from this being shipped without the circuit board screwed in. This green wire here actually provides the negative voltage rail to the filter board. And it is such a short little wire run that it'll be hard to strip and actually solder back in. So I may just attach a new wire there and add it, heat shrink it, put it together right. Oh, and it turns out that this is clear heat shrink. Really. I hate it. Oh my god, I hate that. So I don't use clear. Okay, so I did get good voltages to the oscillator board when powered on, plus 20 and minus 11. And that's what my notes from previous repair say is what you should have. So I will fix that one power connection. There was one wire on the keyboard that was not soldered in place to just like a little holder. It wasn't actually a joint, but it was supposed to be soldered in place. All the others were. So I'll take care of that. And then I'm going to remove this one pin left over from the oscillator removal, and then be able to put in the new oscillator and solder it in. Here's my extended wire. I extended it more than I needed, but it's hard to just work with a little tiny bit of wire. So I slipped the main wire out of the wax lacings, and I'm getting ready to secure the joint, put heat shrink on it, run it back through the lacings, and then solder it back to the board. And then I will have power properly restored to the filter board of this Minikorg. Another tip for you. It doesn't apply as much to a single-sided board like this, because all the traces are here, right? But on double-sided boards, when you're working over them, like soldering these wires together, if you drip solder on a modern double-sided board, you run the risk of jumpering together little tiny fine solder traces. You create an accidental solder bridge between them. And I have seen those. Maybe caused some, but I know I fixed whichever ones I caused. But I've also bought gear that the only problem with it, and it was a real problem, would completely keep it from working right, just because somebody was sloppy and dropped a little solder and made a bridge between two traces. It's actually on it's on a JX8P board with a keybed modification. So what do? Well, you put something underneath your work. Okay? It can be as simple as a little, square of cardboard. Anything to catch the solder that's dripping down, in case there is any. Then you don't have to worry about it. We're just about in. Takes a little wiggling of the individual wires with a thin screwdriver to align them as you're inserting, because they're not, they're not stiff enough to just stick right in like with a regular header pins or something going in a socket. And there's some on the backside, a couple on the backside had to go in as well. So the repair is done. I've looked at this other wire I thought might be loose. I think it's okay. It's just that it's come out of the insulation a little bit, so it seemed worse than it was. So now we just have to solder these in, cut off the excess of the leads, find some screws to put the circuit board back in properly, and then fire it up. I figured I would show you how the keys are held in, because it's not the usual. You notice there's no springs. Instead, there's a strip of, cloth tape, I believe. See where these numbers are written? That strip of cloth tape, let's see if I can really get in there and show you, is right up against these keys. What it is actually doing, it is preventing the keys from going down into the slot that they're fed through. If the key is able to go down, then you're able to unlatch it. See that little piece that sticks out above the slot? If you basically move the key down, say, almost 1/8 of an inch, then you can free it from the slot and the key comes right out. The cloth strip is kind of a pain because it's not something you're going to be able to reuse. So if you remove any keys for any work on them or something, you've got to come up with another way of securing them in. It's like I said, it's basically a piece of tape. So you could use another kind of tape. Not sure what I'm going to do yet. These keys are really dirty. I may just wash them in place as much as possible. You can see the remains of probably Coca-Cola spills. Something. Some nasty sticky residue on them. I think I've lost focus. No! There we go. Yeah. By the way, the IC is in, IC is soldered down. I just have to trim off those excess leads. I lost my cutter, my diagonal cutter. I don't know where it is, so I'm going to go buy a new one and trim those off, and then, wow, it's that close to a test. These are the leads I just trimmed off. There's 13 of them. Get a nice flush cut. You use these flush cut trimmers. Reason I counted them, though, is when you cut them, they kind of fly. And this is two packed circuit boards. And if one of these little leads gets lost, shorts something out, you could cause all kinds of damage. Well, maybe not damage so much, but definitely some bad operations that you just can't explain. And if you if it moves around again, the problem might jump somewhere else. If you don't know that the component is out there, the little lead is out there, shorting things out. So know what you're cutting off. Keep track of them. Make sure you get them all. Just proper electronics hygiene. Yeah. Practice electronics hygiene. Solder blobs. No. Got to be careful with those. Be careful trimming leads. What else? And hygiene. Well, it's a good idea to wrap your wires somehow. I usually just use a zip tie, but this wax lacing technique, and I see it in a lot of vintage gear. It certainly works. I don't think that the knotting technique is real complicated, and it keeps your wires steady and keeps things out of the way, and might even keep them from getting broken off, disconnected from their solder pads. So, more tips for you. I just finished putting in the screws to hold down the oscillator circuit board, and decided to do one more final inspection of all the wiring. Just look at all these wires, right? A lot of wires. And what did I find? This guy. A second broken one to the filter board. So I've got to repair that. I might be able to strip it. I'll have to pull it out of the lacing in order to get some slack. Or I'll just extend it like I did the other one. Not real elegant, but it works. In case you're wondering how I'm managing to strip these wires that are, in this bundle, I'm actually using a utility knife and kind of whittling the plastic down. It's about the only way to do it, because you can't really yank on this like you might need to with a regular stripper. But the utility knife, razor blade, cuts into it just fine. Now it's time for the dangerous video. Is it really fixed? I mean, the keyboard still has to be cleaned up and the one key repaired, but will it play? This is why it's so dangerous. I forgot to plug it in. Okay, now it's danger time. Interesting. This could be a function of my mixer. Okay, I can hear it. The settings are all messed up. All right, so the broken key was acting like a stuck key. Interesting. I got my doubts that this really worked right. And it has had problems for a while. And not just the oscillator. Well, you know. I mean, a bunch of these things are not controlling anything right now. Well, a little more work will be required. All right, the keyboard, while not volts per octave, it still functions as a voltage divider. We can see that. So I've tapped in. First of all, it gets there's 13 volts across the keyboard. And we can see what happens on my multimeter as I press different keys. I find a safe place to park it here. If I press the highest key, I get the full voltage. Press in the middle, got about half. Press the bottom, it should be around pretty low, but not zero, interestingly. So the keyboard is sending increasing voltages as you go up the scale. So the keyboard's working fine.